Hi, everybody. Good morning, good afternoon, good evening. My name is Gopika, and I'd like to tell you about the power of Earth observation and how it can be used to provide for global solutions in this wonderfully global world. So I've got three topics that I'd like to address. The first is the role of Earth observation in our global world and some latest trends. The second is the gaps in using Earth observation. And the third, what the state of inclusivity in remote sensing and some action plans. Let's start off with what is remote sensing. So the definition is that remote sensing is the science, technology, and art of obtaining information about objects from a distance. So that basically means you do not really need to be there near an object to actually measure it or get information about it. So this basically allows for the retrieval of information of regions that are too expensive, too dangerous, or that are not accessible. What we do is we have sensors or instruments on board of various kinds of platforms. These can be uncrewed aerial vehicles, they can be on cars, they can be on aeroplanes, they can be on the International Space Station or on satellites, like you see here. What we call as Earth observation are data that are provided by satellites orbiting our planet. And because it's data that is from around our planet, observing the Earth, it provides a timely way to tackle global, national, and local challenges. And of course, data science is a big part of Earth observation and remote sensing, because in order to understand the images that we're looking at from these satellites, we do need to do a lot of computer techniques. Since 2015, we live in what we call the golden age of Earth observation. And this is because since 2015, many different space agencies across the globe have released a lot of Earth observation data for free. So what you see here are just the Earth observation satellite fleet from NASA and from the European Space Agency. Around our planet today, there are about 11,000 satellites. Of these, about 5,000 to 6,000 are active. That means they're actually monitored and they actually provide active information. And of these 5,000 to 6,000, about 1,500 are Earth observation satellites that are looking at our planet all the time and giving us amazing information about our planet. And this is why we live in the golden age of EO. So this data can be used to provide global solutions to global challenges. This can be for disaster response, for climate change adaptation, and making solutions, for policy making, for sustainable development. I provided two examples here. The upper image shows you sea level change over the last 20 years from satellites that are part of the NASA fleet of satellites. And what you see at the bottom is deforestation from 1992 to 2012 using satellites that are part of the European Space Agency's fleets. This basically shows you that Earth observation satellites can be used to provide this global picture of vulnerable regions, of stable regions, anything but the global perspective. Now, because we can get access to data across the globe, irrespective of borders, this helps in transparency and accountability. So this helps to understand climate change, to reduce carbon footprints, to set reduction targets, for rapid response after natural hazards, for disaster mitigation, for national security issues, for monitoring air quality and pollution. So let me give you just a few examples of the range of applications that Earth observation can be used for. So I started my career working on analyzing deformation after the Haiti earthquake in 2010 while sitting in my office in Germany. So this is the power of Earth observation. I didn't have to apply for a visa. I could just look at the data, and then I could actually analyze deformation after the earthquake. Then I looked at the depths, the deepest ocean floor, to look for oil seeps or hydrocarbon seeps. I was looking at the Gulf of Mexico, and I was looking at the Black Sea using Earth observation data for my PhD. Then I looked at Germany to understand land cover. So all the bright spots here are urban areas, and all the other colors are different kinds of land covers. You can then use a lot of data mining. You can use a lot of data science to extract information about, let's say, how has forest changed over time. And then we are also constantly getting a lot of information about air quality from satellites. Like you see here, this is just the quality of particulate matter over Europe on a particular day in 2019 from Earth observation satellites. So now that we know that Earth observation is really cool, where are the gaps? The first and the biggest gap that I see here is that everybody wants artificial intelligence and machine learning. Everybody wants to get into this latest trend. Yet, to do both of these techniques, you need something called training data. And you do have a lot of training data, but in a few parts of the world, it's not globally available. And that is the biggest gap that I see. So you can do three main techniques for any kind of Earth observation, data analysis. You have the visual analysis. That's the first one you see, where somebody actually sits in front of the computer, looks at these satellite images, and interprets these. The second one is you have the computer do something for you, and then you interpret the results from the computer. That's a semi-automatic technique. And the third one is an automatic technique where somebody actually programs the entire routine in the computer, and the computer does the work for you. That allows you basically for big data analysis. You can then have more techniques like pixel-based, object-based, supervised, unsupervised, and the supervised classification or supervised techniques require training data that is not globally available. We have a lot of free data. Like I said, we're living in the golden age of Earth observation, but all of this data is medium resolution. So when you think about resolution, think about Google Earth. And the closer you zoom in, the more you zoom in, the more you see. And that is the power of resolution. Higher the resolution, the more details you get. So right now, very high resolution data is not affordable by, let's say, science institutions. And we need to now create the accessible age of EO. We're not just in the golden age, but we need to make an accessible age. That basically means we need the cool EO data and the cool data science methods that are producing awesome results to actually be communicated to the right people in the right way. So we need to ask them what they need. That means a farmer in Ethiopia who wants to analyze forest degradation needs to actually be able to understand EO data so that they can use it. So now coming to the topic of inclusivity in remote sensing. There is a lack of representation at all levels. The reason I'm involved in this topic and the reason why I know so much about it is because I am the co-organizer for a voluntary initiative called Sisters of SAR. And if you want to read more about it, feel free to go to the website there. But basically, our aim and our mission is to showcase women in remote sensing. Remote sensing is a field dominated by men, and we want to make sure that women are represented everywhere. On our website, you'll find a portal where you can find women in our field, you can find what they do, where their expertise is, and basically this provides a place where you can find panelists for your sessions, where you can find potential mentors, anything that you need. We're on Twitter, we're on LinkedIn, we have the website, as I said, and we also work with a lot of other diversity, inclusivity, equity, justice organizations. And one of the things we did is we came up with this paper where we audited 30 different journals to see what is the status of the editorial boards. And we found out that there is a lack of representation and diversity in publishing and leaderships, that editors are men residing basically in 4 countries. And we found that authors with non-Western sounding names like mine, we receive harsher criticism and harsher reviews. And in this field of STEM or remote sensing, where, age indices and citations, they make or break your career, it is quite sad to know that gatekeeping happens at such a level. And yeah, this is one of the things that you'll find in our paper. We also recommend action plans. And this photo here is from another session that we organized at the Living Planet Symposium, which is a big conference. If you just Google Living Planet Symposium and Sisters of SAR, you'll find all the information about it. So to conclude, in summary, climate change is here. It's felt globally, but it will affect low to medium income countries the most. I used to watch a lot of Captain Planet as a child, and our Earth is in peril. It's a fact. And Earth observation can help in quick decision making to support all kinds of rapid decision making policies. We need to work together. We need to come together as a planet, as people, as humanity, and make solutions, make training data more accessible, make our field more inclusive. And feel free to get in touch if you want to learn more. And with that, I'd like to thank you for your attention.